So this is question 55, which is the third and final math problem, and it's a density question. But I'm going to show you a way to do it that will apply to this and future ones and doesn't require you to memorize the density equation, which can sometimes be confusing depending on what it is they're asking you to solve for. So if you've got the density equation mastered and you can solve this easily using that, then go ahead and do it the way that you've been doing. If you're consistently getting the right answer, I don't want to add confusion, but if you're not comfortable yet solving density equations, I'm going to show you a slightly different way to do it. So like with the other ones, we want to write what we're given, what we need to find, and any conversions we need to use, but we're going to slightly change what we mean by conversions here, and this will help in future chapters in chemistry. Okay, so aluminum has a density of 2.70 grams per milliliter. It normally you would probably put that into your given, but what I'm going to train you to start looking for is anytime you've got units that look like this, where you've got one unit and then the slash and then another unit, we're going to put that into conversions. And here's why. And we're going to write it slightly differently. So what this means is, and this is only true for aluminum, unlike some of the conversions that we've had in the past would be something like 12 inches equals 1 foot. That's always true. Any problem that you ever have that involves inches and feet, you can use that. This is a conversion that is only true in the context of this problem, but that's okay because this is the only problem that we're using it for right now. And instead of writing 2.70 grams per milliliter, when you're putting it in conversions, you want to write it like this: 2.70 grams equals 1 milliliter. So instead of the units, the slash in the units, which means per, then, and it always means per 1 milliliter. So then we're going to say equals 1 milliliter, because what density really means is that if I have a volume of 1 milliliter of this material, it weighs 2.70 grams. So writing this is equivalent to writing this. And we're going to put it in our conversions because we're going to use it in our ratio. What is the volume? You see the word what, and whatever is right after that question word, it could be what, it could be other words, but usually what is the volume. That is what you want to find. Volume equals something. And it doesn't even say here what units it wants you to find it in. It's going to end up being milliliters, and I'll show you how we figure that out as well, of 546 grams of aluminum. And so 546 grams is what we're given, and it's the mass, but you don't actually need to know that in this case. It would be helpful to know that milliliters is a unit of volume, because that's how you know we're going to basically address this as a conversion from grams to milliliters. And so you kind of need to know that you're going for milliliters in your answer. So just to be able to recognize that milliliters are a unit of volume is important in this case. And so then we're going to set it up like we did with the previous ones with the ratio. And we're just going to follow the order it has in the conversions. I don't know if I mentioned this earlier, but in this case, I'm going to say grams over milliliters equals grams over milliliters. It doesn't matter if you do it backwards. As long as you put the number 2.70 with grams and the number 546 with grams and the number 1 with milliliters and your x with milliliters, it doesn't matter if you do this whole thing upside down. So grams over milliliters equals grams over milliliters. And maybe I'll show you the whole thing backwards after this so you see what I mean, with the milliliters on top and the grams on the bottom, and why it doesn't actually make a difference which way you do this. Okay, so we're going to take what we're given is grams. So we're going to put in our 546 with our grams, and milliliters is what we're trying to find. So we're going to put our x with milliliters, and then on the right side we're going to put the numbers that go along with our conversion. So 2.70 grams and 1 milliliter. Okay, so this is different from what we've seen in the previous two examples, because now our two numbers across from each other are 546 and 1. So when we multiply those, it's going to be 546, and times 1 is just going to stay 546. And then we're going to divide by the number we have left over, which is 2.70. So divided by 2.70, and that equals x milliliters. And so then we're just going to do the math in our calculator. On the left side, 546 divided by 2.70 equals 202.2222222 milliliters. So now we want to make sure we're good in terms of significant figures. Go back to the original problem, and here we have 3 significant figures and 3 significant figures. Throughout this problem, all we did was multiplication and division, so we just need to follow the significant figures rules for multiplication and division, which is use the smallest number of significant figures of anything that you were given. In this case, they're both 3, so it's just going to go out to 202, and then we look one to the right to see if we need to round up, and we do not. So the answer to the correct significant figures is going to be 202 milliliters. And so now, if you're interested, if you're good with this, just stop and go on with that. But if you're worried about putting your grams and milliliters in the right order, I will show you why that doesn't matter. So we're going to do equation and ratio here. So before we did grams over milliliters equals grams over milliliters. So now we're going to do milliliters over grams equals milliliters over grams. So what does matter, without a doubt, is that whatever order you put them in on the left, you have to put them in the same order on the right, and then you have to match up the units with what you're given here. So, and I always put the given on the left and the conversion on the right. That actually, you could swap that around as well, as long as you keep the conversion part together and the given and find part together. So you couldn't put 546 grams here and then take that 1 milliliter and put it up there. You have to keep the given and the find together. So 546 grams, and I just put that on the left side, and that's some number to solve for, x milliliters. And then we get over here, milliliters, we're going to put in our 1 milliliter and our 2.70 grams. And so now what we're going to end up doing is when we cross multiply the 546 times 1, exactly like we had here, and then divide by the number we have left, which is still 2.70. And so we end up doing exactly the same math step here, and then of course end up with exactly the same number there.